No, the receptacle is not considered accessible based on National Electrical Code requirements. According to NEC Section 210.8, receptacles must be installed in accessible locations. The definition of accessible, according to the NEC, is capable of being reached without requiring to remove obstacles or to climb over or under objects. In the scenario you described, the receptacle is located underneath the deck, which would require a person to crawl or stoop to reach the electrical outlet. This does not meet the code definition of accessible. Moreover, the height underneath the deck is only 42 inches. This means that the receptacle is not high enough to be easily reached by an individual in a standing position. Therefore, the receptacle should be relocated to a more accessible location that meets the requirements as set forth by the National Electrical Code. The general requirements for electrical installations are put into place for personal safety. When considering accessibility, there are several factors that are included in the determination. Firstly, the physical obstructions that prevent direct approach to the electrical equipment or receptacle. For example, if the receptacle is located behind a locked door or a permanent structure that needs to be disassembled, it would be deemed inaccessible. Secondly, the height and clearance requirements also play a role. Receptacles are typically required to be installed at a certain height above the finished floor or grade level to ensure ease of use and prevent accidental damage. The specific height requirement can vary depending on the application and local regulations. Thirdly, the working space around the electrical equipment is also critical. Sufficient clear space must be maintained around the receptacle to allow for safe operation and maintenance. This working space should be free from obstructions and provide enough room for a person to access the receptacle and perform any necessary tasks. Accessibility is not only a matter of convenience but also a matter of safety. In emergency situations, it is important to have quick and easy access to electrical disconnects and receptacles to prevent electrical shock or other hazards. By following the National Electrical Code requirements and best practices, electrical installations can be designed and installed to be accessible, safe, and reliable. In the context of hot tubs, the NEC provides specific guidelines for the installation of receptacles and electrical equipment to ensure safety and prevent electrical hazards. These guidelines address various aspects such as the location of receptacles, the type of wiring methods, and the grounding requirements. The NEC requires that all electrical equipment associated with the hot tub be installed in accordance with the manufacturer's instructions and the applicable provisions of the code. This includes the hot tub itself, as well as any pumps, heaters, and control panels. Firstly, the location of receptacles is crucial for safety. The NEC specifies that receptacles installed near a hot tub must be GFCI protected to prevent electrical shock hazards. The distance between the receptacle and the hot tub is also regulated to minimize the risk of water contact. Secondly, the wiring methods used for hot tub installations must be suitable for wet locations and outdoor use. The NEC requires the use of listed and labeled cables and conduits that are designed to withstand exposure to moisture, sunlight, and physical damage. Thirdly, the grounding requirements are essential for preventing electrical shock hazards. The NEC mandates that all metal parts of the hot tub and associated equipment be properly grounded to provide a safe path for fault currents. Grounding conductors must be sized and installed in accordance with the code to ensure effective protection. Additionally, the NEC requires that a disconnecting means be provided within sight of the hot tub to allow for quick and easy shut-off of power in case of an emergency. This disconnecting means must be readily accessible and clearly labeled. It is important to note that the NEC requirements for hot tub installations can vary depending on the specific type of hot tub, the location of the installation, and the local regulations. Therefore, it is always recommended to consult with a qualified electrician or electrical inspector to ensure that the installation complies with all applicable codes and standards. By adhering to the NEC guidelines for hot tub installations, electrical hazards can be minimized and the safety of users can be protected. In general, the National Electrical Code, or NEC, provides comprehensive guidelines for electrical installations to ensure safety and prevent electrical hazards. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. The NEC is updated every 3 years to reflect the latest advancements in technology and safety practices. It is adopted by many jurisdictions in the United States and serves as a standard for electrical installations. One of the key aspects of the NEC is its emphasis on safety. The code aims to minimize the risk of electrical shock, fire, and other hazards by providing detailed requirements for electrical systems. The NEC also addresses specific types of installations, such as those in hazardous locations, healthcare facilities, and swimming pools. The NEC is organized into chapters, articles, and sections, each covering a specific topic. The chapters provide a broad overview of the subject matter, while the articles delve into more specific details. The sections provide the specific requirements that must be followed. The NEC also includes tables and examples to help clarify the requirements. The NEC is not a substitute for engineering judgment. It is a set of guidelines that must be applied in conjunction with sound engineering principles. The NEC is intended to be used by qualified electrical professionals who have the knowledge and experience to design and install electrical systems safely and effectively. The NEC is a valuable resource for anyone involved in electrical work. By following the NEC requirements, electrical installations can be made safer, more reliable, and more efficient. When considering the requirements for receptacles, several factors come into play to ensure safety and compliance with the National Electrical Code. Firstly, the type of receptacle is important. The NEC specifies different types of receptacles for various applications, such as general-purpose receptacles, GFCI-protected receptacles, and arc fault circuit interrupter or SI protected receptacles. Secondly, the location of receptacles is also critical. The NEC provides guidelines for the placement of receptacles in different areas, such as dwelling units, bathrooms, kitchens, and outdoor locations. These guidelines aim to minimize the risk of electrical shock and other hazards. Thirdly, the spacing of receptacles is regulated by the NEC to ensure that there are enough receptacles to meet the needs of occupants and prevent the use of extension cords, which can be a safety hazard. The NEC also requires that receptacles be installed in accessible locations so that they can be easily reached and used. Additionally, the NEC addresses the wiring methods for receptacles. The code specifies the type and size of conductors, the methods of termination, and the grounding requirements for receptacles. The NEC also requires that receptacles be properly grounded to provide a safe path for fault currents. Furthermore, the NEC mandates that receptacles be protected by overcurrent devices, such as circuit breakers or fuses, to prevent overloading and short circuits. The overcurrent devices must be sized appropriately for the receptacle and the circuit it serves. It is important to note that the NEC requirements for receptacles can vary depending on the specific application and the local regulations. Therefore, it is always recommended to consult with a qualified electrician or electrical inspector to ensure that the installation complies with all applicable codes and standards. The location of a receptacle also factors into the decision of accessibility. The location of electrical receptacles is crucial for safety and convenience. The National Electrical Code provides guidelines for the placement of receptacles in various areas to minimize the risk of electrical shock and other hazards. In dwelling units, receptacles are typically required to be installed in every room, including living rooms, bedrooms, kitchens, and bathrooms. The NEC also specifies the maximum distance between receptacles to ensure that there are enough outlets to meet the needs of occupants. In kitchens, receptacles must be installed along countertops and near sinks to provide power for appliances and other devices. The NEC also requires that GFCI-protected receptacles be installed in kitchens to prevent electrical shock hazards. In bathrooms, receptacles must be installed near sinks and other water sources. The NEC also requires that GFCI-protected receptacles be installed in bathrooms to prevent electrical shock hazards. Outdoor receptacles must be installed in weatherproof enclosures and protected by GFCI devices to prevent electrical shock hazards. The NEC also requires that outdoor receptacles be located at least 12 inches above grade level to prevent water damage. In commercial buildings, receptacles must be installed in accordance with the needs of the occupants and the requirements of the NEC. The NEC provides guidelines for the placement of receptacles in offices, retail spaces, and other commercial areas. In industrial settings, receptacles must be installed in accordance with the requirements of the NEC and the specific hazards of the location. The NEC provides guidelines for the placement of receptacles in hazardous locations, such as those with flammable materials or explosive atmospheres. The height of the receptacle is also a factor to consider for accessibility. The height of electrical receptacles is an important consideration for accessibility and safety. The National Electrical Code provides guidelines for the height of receptacles in various locations to ensure that they are easily accessible and prevent accidental damage. In dwelling units, receptacles are typically required to be installed at a height of between 12 inches and 48 inches above the finished floor. This height range allows for easy access by most people, including those with disabilities. In kitchens, receptacles that serve countertop surfaces must be installed at a height of between 15 inches and 20 inches above the countertop. This height range provides convenient access to power for appliances and other devices. In bathrooms, receptacles must be installed at a height of at least 12 inches above the finished floor. This height requirement helps to prevent water damage and electrical shock hazards. Outdoor receptacles must be installed at a height of at least 12 inches above grade level. This height requirement helps to prevent water damage and ensures that the receptacles are accessible for outdoor use. In commercial buildings, the height of receptacles is typically determined by the needs of the occupants and the requirements of the NEC. The NEC provides guidelines for the placement of receptacles in offices, retail spaces, and other commercial areas. In industrial settings, the height of receptacles is typically determined by the specific hazards of the location. The NEC provides guidelines for the placement of receptacles in hazardous locations, such as those with flammable materials or explosive atmospheres. It is important to note that the height requirements for receptacles can vary depending on the specific application and the local regulations. Therefore, it is always recommended to consult with a qualified electrician or electrical inspector to ensure that the installation complies with all applicable codes and standards. Ground fault circuit interrupter, or GFCI, protection is a critical safety feature for electrical receptacles, especially in areas where water is present. A GFCI is a device that monitors the current flowing through a circuit and quickly interrupts the power if it detects a ground fault. A ground fault occurs when electricity flows through an unintended path to ground, such as through a person's body. GFCI protection is required by the National Electrical Code in various locations to prevent electrical shock hazards. In dwelling units, GFCI protection is required for receptacles in bathrooms, kitchens, garages, and outdoor areas. In bathrooms, GFCI protection is required for all receptacles within 6 feet of a sink or shower. In kitchens, GFCI protection is required for receptacles that serve countertop surfaces. In garages, GFCI protection is required for all 120 volts, 15 amps and 20 amps receptacles. In outdoor areas, GFCI protection is required for all receptacles that are readily accessible. In commercial buildings, GFCI protection is required for receptacles in bathrooms, kitchens, and other areas where water is present. In industrial settings, GFCI protection is required for receptacles in hazardous locations and other areas where there is a risk of electrical shock. GFCI protection is typically provided by a GFCI receptacle or a GFCI circuit breaker. A GFCI receptacle is a special type of receptacle that has a built-in GFCI device. A GFCI circuit breaker is a circuit breaker that provides GFCI protection for an entire circuit. When a ground fault occurs, the GFCI device quickly interrupts the power to the circuit, preventing electrical shock. GFCI protection is an essential safety feature that can save lives. It is important to ensure that all receptacles in areas where water is present are protected by GFCI devices. When working with electricity, it is essential to prioritize safety to prevent electrical shock, fire, and other hazards. Firstly, always to energize the circuit before working on any electrical equipment. This can be done by turning off the circuit breaker or removing the fuse that supplies power to the circuit. Secondly, use appropriate personal protective equipment, or PPE, such as rubber gloves and safety glasses. Rubber gloves protect against electrical shock, while safety glasses protect the eyes from flying debris. Thirdly, inspect all electrical equipment before use. Look for any signs of damage, such as frayed wires, cracked insulation, or loose connections. Fourthly, never work on electrical equipment in wet or damp conditions. Water is a conductor of electricity and can increase the risk of electrical shock. Fifthly, use the proper tools for the job. Electrical work requires specialized tools that are designed to be safe and effective. Sixthly, follow the National Electrical Code, or NEC, guidelines for electrical installations. The NEC provides comprehensive requirements for electrical systems to ensure safety and prevent hazards. Seventhly, be aware of your surroundings. Look for any potential hazards such as overhead power lines, exposed wires, or water sources. Eighthly, never overload circuits. Overloading a circuit can cause the wires to overheat and start a fire. Ninthly, use GFCI protection in areas where water is present. GFCI devices protect against electrical shock by quickly interrupting the power when a ground fault occurs. Tenthly, if you are not comfortable working with electricity, hire a qualified electrician. Electrical work can be dangerous, and it is best to leave it to the professionals. By following these safety precautions, you can minimize the risk of electrical hazards and protect yourself and others from harm. Proper wiring methods are crucial for ensuring the safety and reliability of electrical systems. The National Electrical Code provides detailed guidelines for wiring methods to prevent electrical shock, fire, and other hazards. Firstly, use the correct type of wire for the application. The NEC specifies different types of wires for various uses, such as general-purpose wiring, appliance wiring, and outdoor wiring. Secondly, size the wires properly for the load. The wire size must be adequate to carry the current without overheating. Thirdly, protect the wires from physical damage. Wires should be run through conduits or other protective enclosures to prevent damage from impact, abrasion, or moisture. Fourthly, make proper connections. All wire connections must be secure and tight to prevent loose connections, which can cause overheating and arcing. Fifthly, ground the electrical system properly. Grounding provides a safe path for fault currents and helps to prevent electrical shock. Sixthly, use the correct type of conduit for the application. The NEC specifies different types of conduits for various uses, such as rigid metal conduit, electrical metallic tubing, and flexible metal conduit. Seventhly, support the wires and conduits properly. Wires and conduits must be supported to prevent sagging and strain on the connections. Eighthly, seal the conduits to prevent moisture from entering. Moisture can cause corrosion and electrical shock hazards. Ninthly, label the wires and conduits clearly. Labeling makes it easier to identify the wires and conduits for maintenance and troubleshooting. Tenthly, inspect the wiring regularly. Regular inspections can help to identify and correct any potential problems before they become serious hazards. By following these wiring methods, you can ensure the safety and reliability of electrical systems. Understanding the local electrical regulations and codes is crucial for ensuring compliance and safety. The electrical regulations and codes are established to protect people and property from electrical hazards, and they vary depending on the location. Firstly, identify the local electrical authority. This is the government agency or organization that is responsible for enforcing electrical regulations and codes in your area. Secondly, obtain a copy of the local electrical code. This document contains the specific requirements for electrical installations in your area. Thirdly, familiarize yourself with the code requirements. Read the code carefully and understand the requirements that apply to your project. Fourthly, obtain any necessary permits. Many electrical projects require permits from the local electrical authority. Fifthly, hire a qualified electrician. A qualified electrician will be familiar with the local electrical regulations and codes and can ensure that your project complies with the requirements. Sixthly, schedule an inspection. Once your electrical project is complete, you will need to schedule an inspection with the local electrical authority to ensure that it complies with the code. Seventhly, correct any violations. If the inspector finds any violations of the code, you will need to correct them before the project can be approved. Eighthly, keep records of all electrical work. This includes permits, inspection reports, and any other documents related to the project. Ninthly, stay up to date on changes to the code. Electrical regulations and codes are updated periodically, so it is important to stay informed of any changes that may affect your work. Tenthly, consult with an electrical engineer. If you have any questions or concerns about the electrical regulations and codes in your area, consult with an electrical engineer. By understanding and following the local electrical regulations and codes, you can ensure that your electrical project is safe and compliant.